Hello guys, in this video we are going to see about the Scikit Learn project. So generally what is the Scikit Learn? In the previous video we have discussed about what is Scikit Learn. So I will give you a recap about what is Scikit Learn. So generally Scikit Learn is an machine learning module where we can use to do regression, classification and clustering. So it's also used in both supervised and unsupervised machine learning. So in this video we are going to see how to do a Scikit Learn project. So this is a basic project. So let me start. So first we need to install the Scikit Learn library into our system. So this is the code where you can install the Scikit Learn in your Google Colab, and then we need to import that module, import Scikit Learn and import pandas.pd and numpy, and we are getting the data set directly from a Scikit Learn. So this is what load this iris dataset. So this is a general dataset where we can see this most popularly used dataset. So we are loading the dataset into the variable dot into this iris. Okay, then we are loading into this in the data frame. Okay, in this column we are given as iris dot feature name. This is nothing but extracting the features except the data. We can say this is as an shading. This column refers to this sepal length, sepal width, and petal length and petal width. And this df.iris dot shed is nothing but it will only display the first 5 of the data frame. If I run this, you can see this. Yeah, you can see. And the tail represents the last 5 values which is there in the data frame. So next, data visualization. This data visualization is an important part in viewing the data, whether we are using a correct data set or not. So from pandas.plotting, import scatter matrix. Actually we have many type of data visualization tools, but here I am using this scatter matrix, and then I am importing the matplotlib as PLT. So we are going to visualize the data on the basis of the figure size is equal to 10:10. So this is nothing but the size of the graph. Okay, so what value are we are going to plot? So this is what that is, df underscore iris. Okay, this iris dataset will be plotted on this four features. Okay, so the first one will be the sepal length, second one will be the sepal width, third one will be the petal length, and fourth will be the petal width. So and also in the bottom will be the same. So this is what the scatter matrix seems to be, and then we are going to display it in a using this Seaborn module. I'm importing this as an SNS. So this will be the general styling code to display the graph. Okay, and this is nothing but to load the dataset into the graph and setting the color. Hue is nothing but the color of the dots. So here we are separating this by the species color, which is refers to the RBG, red, blue and green. Okay, so the same also in the SNS we have some 4 features, right? So that will be up to some 16 graph. Then this is the basic coding part where we are learning and predicting the data set. First we will be assigning and converting the data features into an array. For that we need to use numpy. Okay, so this df.species is converted into the labels, and this label encoder, actually what is this label encoder means, which is able to convert the categorical value into an continuous value. Okay, let me see. After loading this label encoder, I am setting this module into a variable called LE. Right. After this LE, I am going to drop some of the I'm going to drop some of the features which are in my data frame as these three, because these three I'm going to use only the label in the in the petal length and the petal width, right? So df.features will be to dict of orient is equal to records. Then okay, this I already mentioned that this dict vectorize it is used to convert the categorical form into an continuous form, right? So features is equal to vec dot fit transform of df features to an array. So this df features will be having except this sepal and sepal with and species, right? So now we are training and testing the data set, and this is the most important part in the coding part. So there is an pre-processed library which is called train test split, where we can import it from, right? That is called as sklearn dot model selection. So like we need to import it first, and then we need to assign a four type of variable, where we generally call it as x train, y train, and x test and y test. But here we are using feature train and feature test, labels train and label test. Okay, and these these are the two variables, which one will be the dependent and another will be the independent. And according to the total number, I mean the total number of size, we are assuming only the 20% to a test data, and remaining will be for the training data, right? So the successfully the training set and the test set is done, right? After that we are going to use three algorithms to check the accuracy, which will give the best accuracy. So basically if we see in Scikit Learn, so that is not be having only one algorithm, right? We have support vector machines and KNN, also logistic regression, and some more. But in this video, like we are going to see only these three, right? Okay. From where do we import this support vector machine? Actually, what is So, what is this support vector machine? This support vector machine, uh, how it is differentiated by logistic regression. Generally, the support vector machine can handle non-linear solution, whereas logistic regression can handle only this linear solution. Okay, linear SVM handles outliers better, as it is derive maximum margin solution, and hinge loss in this SVM outperforms log loss where in this logistic regression. Okay, so generally these both are used for this classification purpose, but somewhat both and both this algorithm have advantages and also disadvantages. Now we coming to this k nearest neighbor. K nearest neighbor is a non-parametric model, whereas our logistic regression is a parametric one. So, and then this KNN is comparatively slower than this logistic regression, just an execution time and the running time. And also this KNN support non-linear solution, whereas already we mentioned that LR supports only linear solutions, right? And the last part will be the LR can derive confidence level, I mean the about its prediction. So the prediction for this logistic regression is a bit larger than the KNN, I think so. So whereas in KNN only can only output the labels. So let we see in action. So generally in SVM we'll be importing from sklearn.svm. So import support vector classifier. So SVM model linear, we are assuming and just training the data sets. I mean not training, but we are fitting into this. So features.train and label.train. I mean label train. Okay. Then we are getting the fitted data set for the predictions. So SVM predictions will be given upon SVM model linear dot predict this features test, right? After that, we are testing the test accuracy here. So we are giving the features test and label test. If you see generally, what we are doing is we are fitting with the training data set, and we are uh, trying to get the accuracy of this testing data set, right? So if we run this, we'll be getting the accuracy of this iris data set for this testing one will be 0.96, which is a high value. Okay, and same for this training accuracy, where we will be giving or okay, for this training we are also I mean for accuracy of the training data, we are using this features train and this label train. Okay, and the tech and the training accuracy for this iris dataset will be 0.975. Cool, right? And then we are using k nearest neighbor. Okay, in this k nearest neighbor, and this is the syntax for that. Like we are using 7 neighbors. Actually, generally this k nearest neighbors which is used, like uh, we'll be plotting the data in a point, and we'll find the maximum, I mean the minimum distance between the 2 points, right? So those are called as neighbors. So we are setting up a 7 neighbors which are close to close. I mean the 7 minimum distance between the points, or we can say the how to say, like a point will be there, and 7 points will be surrounded that. Within that, the minimum distance of the 7 points will be taken, right? So now we are training with the features and the label train. Here we are getting the training accuracy, and this accuracy is important, and even this will be considered under this import kneighbor classifier for KNN, right? So if you want to know the score, then the score is being displayed. And now comes the last, this one is the logistic regression, where we are implementing the same part. Okay, so this will be the model, so where we can take the logistic regression module into our Python. So classifier is equal to logistic regression, just loading the module into my variable, and classify dot fit features train label train. Okay, then prediction on training data set will be the same. So what I'm trying to do here is I want to test my x train variable, which means the feature train variable, and this will be the evaluation matrix where I need to get the accuracy score with my Scikit Learn dot metrics library. Okay, now accuracy on training data, which is the same like what we have imported just right now. We have to use that. So if we use that and printing the training accuracy on one training data set, it will show 0.95, and same if we test for the testing data set, it will be showing 0.966667. Okay, the summary will be on the, yeah, logistic regression which is there. It's giving accuracy of 0.95 with the training data set of 0.96667. So same in KN, the training data set will be of 0.98333, and test data will be of 6. So you can see the KNN is accuracy of the KNN will be as slight lesser than SVM and also logistic regression. So thank you guys.